All right. So what we have here is finding out what happens if you change the size of something. Like you double its length, how does that affect its area? So one of the places where sometimes we increase the size or decrease the size of something is a picture. Sometimes you want to make an enlargement to make a big picture on the wall. So what we have here is someone has taken a picture and they've got a 4-inch by 6-inch print. So we can draw a picture of that. If I draw that picture and it's 4 inches here and 6 inches here, the area would be length times width, which would be 4 times 6, would be 24 inches squared, or 24 square inches. So when you're writing your units, I don't mind if you write inches squared, or you could write, I think on your formula sheet it might be written that way, square inches. Either way is fine. Sometimes, depending on where the mark allocations are on the test, there is sometimes a half a mark for the units. So if you forget to write the units, you could lose that half a mark. Now, if you double each dimension, so here's part B. We have originally a 4 by 6. If you double this and make it 8 and double this and make it 12, will the area be double? Remember, the area here was 24 inches squared. Look what happens when you double both sides. I want you to think about this rectangle right here. How many of those do you think you could fit into? 4, right? Because if I take one, whoops, not that one. Take one here, another one there, another one down there. And of course, if I would have drawn it perfectly, it would match up exactly. So yeah, 4 of them fit in there. So when we look at our area, when we do 8 times 12, and we get an area of 96 inches squared, we notice that that is 4 times bigger than the original one. So doubling each dimension, how many times larger than the original print is in the enlargement? It is 4 times larger. So when we talk about the size of something, here we're talking about its area. It takes up 4 times the area. Suppose you wanted to make it even bigger and take the original length and width and multiply them by 4 to make a huge plaque. So when we look at that, if you multiply it by 4, and I'm not going to actually draw it to scale here, I'm just going to draw a bigger one. If I multiply this side by 4, it's now 16 inches. This side is now 24 inches. And 16 by 24 gives us 384 inches squared. And this one to this one is now 16 times larger. So we can write here that in C it is now 16 times larger. Something to notice. When we doubled the dimensions, so we times the dimensions by 2, the area was times by 4. When we quadrupled the dimensions, when we did the dimensions by 4, the area was 16 times bigger. So if you change the sides by 5,
It would be 20.
no, it would be 25 times bigger. If you change the sides by 7, if you multiplied each of the sides by 7, the area would be 49 times bigger. Because what happens is, you know how it's length times width. If you're multiplying this side by 2 and this side by 2, you have 2 extra 2's that you're multiplying by. So your area becomes times by 4. What is the area in part C? It is 384 inches squared. Compared to the original one, that is 16 times larger. Your turn. Try this one. If he tripled the print, what would the new dimensions be? When you tripled it, you get 12 by 18. The new area, 12 by 18, 216 square inches. This is 9 times bigger than the original print.